Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will focus on calculus application, more specifically the calculus of motion. This is lesson 5 of 5. Have you subscribed yet? You can also visit my website, onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Let's start with the maths. Example 1. A particle moves along a straight line. The distance s in meters of the particle from a fixed point on the line at the time t seconds and t is greater or equal to 0 is given by, and then there's your equation. The s of t is equal to 2t squared minus 18t plus 45 for the distance. Question 1. Calculate the particle's initial velocity. Velocity is the rate of change of distance. Now what this means is when you have an equation for the distance and you find the first derivative, then the first derivative means you find the equation for the velocity. So therefore the first derivative is 4t minus 18. And then the question says calculate the particle's initial velocity. That means this is at time is equal to 0. Therefore, in t's place, you substitute 0 and the answer is minus 18 meters per second. Question 2. Determine the rate at which the velocity of the particle is changing at t seconds. That means they want you to give the acceleration of the particle. Now what you do is, when you find the first derivative, you find velocity. And when you find the second derivative, then that means the rate at which the velocity changes or acceleration. So in this case, the second derivative is 4 meters per second squared. Number 3, after how many seconds will the particle be closest to the fixed point? So that means the minimum. And where do we find the minimum? The minimum is the first derivative equal to 0. Therefore, there's our first derivative. And then when we equate it to 0, we can solve t. Negative 18 walks across, we divide away the 4, therefore at t 4,5 seconds. Example 2. The displacement s, the distance from a fixed point of a car moving towards a fixed point after t seconds is given by the equation s is equal to t cubed minus 9t squared plus 24t plus 8. So that equation is the equation for the displacement or the distance. Question 1. Determine an expression for the velocity v of the car. Remember, velocity is the rate of change of distance with respect to time. So what that means is when you have the equation for the distance or the displacement and you find the first derivative, then you find an expression for the velocity. Therefore, in this case, when we have the displacement, ds over dt is equal to 3t squared minus 18t plus 24. So that expression is the expression for the velocity. Question 2. Calculate the time t during which the car was reversing. So that means the velocity is smaller than 0. Now we have an equation for the velocity. That was the first derivative. And now we will equate that one and we'll make it smaller than 0. Then I'm going to solve t now. So what I will do is I will divide right through by 3 and I end with t squared minus t plus 8 is smaller than 0. And can you see this is an inequality? And then we will factorize t minus 4, t minus 2 smaller than 0. And then to deal with this inequality, we will find the critical points, and they are at 2 and 4. And then we make a help sketch with the two critical points at 2 and 4. And then, since all of this is smaller than 0, we will find the answer there in between 2 and 4. Therefore, that's your answer. T is smaller than 4 or T is greater than 2. Example 3. If the displacement s in meters of a particle at time in seconds is governed by the equation s of t is equal to half t cubed minus 2t, find acceleration after 2 seconds. Now, first of all, if this is the displacement or the distance, then when we find the first derivative, 3 over 2 t squared minus 2, that one means velocity. And then when we find the second derivative, so we derive again, then the answer is 3t, and that equation is then acceleration. And then here they wanted for find its acceleration after 2 seconds. Therefore, into the second derivative in t's place, we will substitute 2. Therefore, the acceleration is 6 meters per second squared. Example 4. A stone is thrown vertically upwards and its height in meters above the ground at time t in seconds is given by h of t equals 35 minus 5t squared plus 30t. Number 1. Find its initial height above the ground. So what that means is there is the height equation. Initial height means at time equals 0. Therefore, in t's place, we substitute 0. Everywhere we see a t, and then the initial height will be 35 meters. Question 2. Find the initial speed with which it was thrown. So now for speed, we will find the first derivative. So there's the equation for the height. The first derivative is equal to minus 10t plus 30. But the question says find the initial speed. Therefore, that implies at time equals 0. In t's place, we substitute 0. Therefore, the initial speed was 30 meters per second. Question 3. Find the maximum height above the ground that the stone reached. So now maximum minimum first derivative equals 0. There's your original equation. First derivative minus 10t plus 30 equals 0, and we solve t. Minus 10t is minus 30, therefore t is equal to 3. So this is happening at t is equal to 3. And we know now maximum minimum, we find the first derivative equate to 0. And then to find the height, it means this is happening at time is equal to 3. So into the original heights equation in t's place, we will substitute 3, and the height, the maximum height is 80 meters, where at time 3 seconds. Question 4, give the acceleration of the stone. Therefore, there's height. When you get the first derivative, you get a velocity, and when you get the second derivative, then it's acceleration. Therefore, the acceleration is minus 10 meters per second squared. Now you know everything there is to know on calculus of motion. There's also 2 playlists for you. Click on the link in the left-hand corner. That is where you will find calculus basics, more specifically first principles, rules of calculus, equation of a tangent. And then also, if you click on the link on the right-hand corner, there you will find everything on calculus graphs, how to sketch the cubic function as well as finding the equation of a cubic function. This is Miss Pythagoras signing off till next time.